Hello everyone, this is another student's quest with a new question. The question says that consider a parabola and the parabola equation is given y is equal to x squared by 4. It means I can see that this is nothing but x squared is equal to 4y. And the point f is given that is 0, 1, which is the focus of the parabola. And there are some series of points on which there is a1 is x1, y1, a2 is x2, y2, a3 is x3, y3, up to an xn, yn are n points on the parabola such that the xk means each x coordinate of this such lines are actually positive. And angle OFK, the angle made by the points connected from the origin, focus and the particular point on the parabola is k pi by 2n, where k goes from 1 to n. Then we have to find out the limit of this summation, which inside the summation I have the f ak means we are just finding the distance of any point on the parabola from the focus. So this question is actually the combination of two concepts like coordinate geometry and the limit. And who knows, because there is given 1 by n, perhaps this will turn into definite integration of limit of sum, so the also integration. So before you see the solution, I request you to solve it by your own, then you will see how the solution looks like. All right. And one thing I also want to suggest that if you are sending me the question, please mention your name, class and the place, so that I can also mention the same thing in my video. All right, so let's start the solution. So here you can notice that the parabola is given like this. So this is the open up parabola. So let's draw it first. So I have a schematic diagram of the parabola like this. This is the parabola I have. I think I have taken the bad color. Let me choose some a little bit brighter. So let's say this is the parabola I have, and the focus of the parabola, you can notice that this is 0, 1 is there. It means the focus is 0, 1. So because here you can notice that x squared is equal to 4y, so the a value for this parabola is going to be 1. So the focus is 0, 1 for that. So there is a 0, 1 here, and that is called to be f. Now there are some series of the points. So let's say I have the first point over here, this is a1, and let's say this is the ak or anywhere. Let's say this is the ak, I don't know, and between then a2 and all these things. So let's take one single point and try to understand what is happening over there. So I'm connecting this f to ak, and there is a o already here. You notice what is actually required in this question is, see carefully, the angle OFAK I need is a k pi by n. So O, F and AK means they're asking for this angle. This angle is, let's say, the theta k. Why I'm calling theta k? Because it's convenient to write. So let me write it here. Theta k, I'm saying that's k pi by n. And when the expression will be simplified, I will substitute this k pi by n at the last. So this is the angle I have, and this angle is theta k. Now notice what we can find out actually. So let's take a parametric point on this curve. So you can see that I can say ak is xk comma yk, or directly we can write the xk is nothing but, because I have x squared by 4. So what is the parametric form we can write for that? Let's say t the parameter, but t the parameter again I'm writing with the index k actually, because each point has a different parameter. The a1 has a different parameter, ak has a different parameter, means the parameter in the sense that it depends upon the value of k. So now what I'm going to do it, I'm writing this x as 2tk and y will become tk square, correct, because 2t comma t you write, t square you write for. So now notice what we need. Actually we need this thing, the summation of this term here, and then we are taking the limit. So what I'm going to do is I'm writing the s first, the summation, and then simplified form of this we will put in the limit, and then we find the limit. So I have the distance of AK from this. All that I have to find out this AK. So how do we do that? You notice that the distance between the A and F, means the any point on the parabola to the focus, is equal to the perpendicular drawn from the point of the directrix. So you know this fact for the parabola. So this is the directrix I have, and if I draw perpendicular from this M, let's say this AKM or AKMK, because for every point I have different point of the photo perpendicular. So that's the thing. So let's first evaluate what is FAK. I want to say FAK I can write as AKMK, means this is the distance of the point, the vertical distance of the point from this directrix. But you notice that the directrix is always a unit behind the vertex of the parabola. So what we can say that this distance is already A I have, and wherever you take the point, let's say I drop this perpendicular over here from there, and you can just realize that this length is already A, and this length I have as the YK, means the distance of the origin from this point, which is nothing but the y coordinate of this point AK. So this I can write as A, that is 1, plus, and the y coordinate is YK, that is TK square. So all that I have to find out TK, and if I find the TK, that will be convenient. But how do we find the TK? Because I have to involve this the angle, I need to find the TK in terms of the angle. So how do we do that? You see, what is TK and the theta related, we have to understand. See here, this angle is actually theta I am taking. If this is theta and this length is xk and this length is the distance between AK and FK, that is not now required. But what is this gap? This gap is 0, this length is 1 actually from here to here, and you are taking the y coordinate of this. I mean to say, suppose I have this triangle like this, for every point this kind of situation is going to happen. So let's take this is angle theta k, this point is already 0, 1, it means this length is 1, and you are measuring the distance from this point. Let's say this is the point origin here. It means this particular point is YK unit away from the origin, because you are taking this thing, and this particular length is xk unit away from the y-axis. So in this way, what we can say, the tan theta k is nothing but the tan theta k is going to be the xk by yk, not yk, 1 minus yk, 1 minus yk. Now let's substitute the values of xk and yk as the parameter. So what we identify that the 2 xk is 2 tk, so 2 tk, and the yk is tk square, so 1 minus tk square. Now as you see this thing, do you identify there is a trigonometry going to be happen? Yes. So this is theta k here, and I just bring this tan in this side, so we get theta k is equal to tan inverse 2 tk divided by 1 minus tk squared, and which is nothing but 2 tan inverse tk, 2 tan inverse tk. So I got the tk in terms of theta k. How I got it? Just send this to this side. So theta k by 2 is equal to tan inverse tk, and so the tk is nothing but tan theta k by 2. So this is the value of tk we got, and the length we already have established in terms of tk. So this is the length here I have. The FAK is 1 plus tk square. So it's now very convenient, because as soon as you substitute this tk there, it will turn into the 1 plus tan square theta k by 2. So let's substitute it there. So the summation, now I'm writing that summation, k goes from 1 to n, and this is going to be 1 plus tan squared theta k by 2. The 1 plus tan square theta k by 2 is nothing but sec square theta k by 2. Now I'll substitute the value of theta k. Theta k is, notice, it was already given pi k by 2n. So there no such harm. I can substitute easily. That is going to be 6 squared and pi k by 2n. So pi k by 2n will become pi k divided by 4n. And this is the real setup we have, the easiest setup for the limit evaluation. So let's substitute this summation at the place of this whole thing inside the limit evaluation term. So we substitute it. So what if we get it here? Let's say the limit we are evaluating, let's call it a limit L, is going to be limit n approaches infinity 1 by n, and the summation k goes from 1 to n sec square pi by 4 into k by n. Now notice it is actually reminding you for applying the definite integration limit of some property or the formula. You can notice that this is k by n. It is actually acting as r by n. If you are familiar or emotionally attached with the symbol r there in the summation. So this is r by n and this is 1 by n there. It means it's already a function of r by n. So each r by n means basically, yes. So there is only one r by n, but whenever you see inside the r by n, you have to replace with x. So you notice r by n should be replaced with x and 1 by n should be replaced with dx. And the bounds, the k is equal to 1 to n will turn into 0 to 1 to n will turn into 0 to 1. So we'll get to 0 to 1, and this is going to be sec squared pi by 4 x dx. Now nobody can stop you to integrate and find the value. So what we get it here, tan pi by 4x and multiplied by the reciprocal of the 4 by pi by 4 is 4 by pi, and this thing we have to evaluate from 0 to 1. So at 1, tan pi by 4 into 1 will become 1, at 0 it will be 0, but it will multiply by 4 by pi. So the answer you got is 4 by pi as the final answer. So this was the way we can solve it easily. There are many ways we can do, but I found it a little bit convenient. So see you in the next video with some other students' question, and please send your name as well as your class and the place. I will like to mention your name in the video. All right. See you in the next video with some other interesting question. Stay math active.